Cool. Okay, great. Good morning again. Welcome, everyone. Today, the topic is around open models. So AI open models, you might have heard of them quite a bit, especially lately on the news, on discourse, on LinkedIn, things like that. We are actually going to talk about what they are, how to use them, the general landscape, and then we'll get into a demo on using it in a real analysis, for example. And the This lesson is in collaboration with actually with Moonshot AI, which makes Kimi. You might have heard of them in the last few weeks when they came out with Kimi K3, the model that has the most parameters ever released for an open source open weight frontier model. So we'll be taking a look at that in our demo, and yeah, excited to sort of like bring you guys the along on the concept of open models. Okay, cool. So let's see. So what is an open model, right? Like I think that's a very valid question. Saw that on the chat, and thank you, Valens, for answering that. So imagine just think of it as everyone here has used ChatGPT. You've used Claude probably on the chatbot, like on the website through their chatbots. So the idea for what a closed model is it's similar to those where you type in a question and then you get an answer back. But then all the computation for getting you the answer happens over at Anthropic or OpenAI servers. Like it's happening on their computers. You have no clue what they do. You have no idea what their model does for getting you the answers that you're getting. So that's kind of like the way to think about it. And like you'll see a token count of some sort where like, hey, this is a complicated question. It takes some amount of computation, and you're getting charged for that. So that's roughly the idea, where it's it's closed by definition, so you don't see it. Open, on the other hand, is the weights are transparent. So think of the weights of a model as just the numbers that really make the model the model. So like you can download the entire model. You can run it on your own machines. You can even run some of the smaller models on your laptop. For example, you can change things, you can ask it, it will compute and give you back an answer. And you know exactly why it gave you the answer, for example, for based on your questions, for example. So the analogy here is almost like renting versus owning. So renting is like, you're renting models from the frontier closed labs. They never make it open to for like it's their secret sauce. That's how they're able to kind of like monetize on it, have the chart, have the pricing power, and all that kind of stuff. Open is the opposite, which is you have the ability to own it. They just make it available to everybody. So hopefully this is intuitive. This is clear. And so if you kind of like get into one step into this, like what does owning actually get you, right? There are a few things that are really important for why this is, like Jensen Huang, all the tech leaders have signed some sort of like open letters to the government to be like, hey, we need open models. And there are a few things. Thing number one is privacy. So your data technically runs on your own machines. Like if you actually, let's say, like download the model and then run it on your own hardware. So your data actually never gets sent anywhere, right? Because all the computation is happening on your own machine. And so, like I think there's if you're renting it from a vendor, let's say Anthropic or OpenAI, you are at their mercy and their promise to be like, we'll never train on your data or whatever it is. That's what they say. Whether that's true or not is like, you take the risk. But if you're running it on your own machine, then even if you cut off your internet, it will still run as long as you have electricity. So that's kind of like the idea. The second piece here is the ability to fine tune the model. So you can actually change the the model with your own data, because now you know the weights of it. And so, like maybe you have proprietary data around, let's say like healthcare, or like some sort of verticals that are extremely, beneficial for the model to behave, or to have that knowledge intimately. Then you can actually do that with open weights. You can do that in closed models as well, but like again, like you don't own any part of that. And then the third is just simply nobody can take it away, because now you own it by definition. If you remember, maybe like a couple months ago, or maybe like, yeah, like 2, 3 months ago, forgotten by now, Fable 5 from Anthropic released for a couple of days, and then they had to be pulled back because the U.S. government says, "Hey, this is too risky. Like we can't allow this until we have further review on this." So anything that you sort of like depend on others is basically subject to availability, private terms and service, and things like that, where it can be pulled away, like with in a moment's notice. So that's another sort of like thing that open models give you, where you have a lot more control over it, and it can't just be yanked away because now it's yours. So really, just the main idea is it's yours. Like I think that's a little bit nuanced, but high level, that's kind of like what how you can think about it. Cool. Okay. So who makes them now, right? Like we've probably, or many people have probably heard of, open models, like challenging the closed frontier models of them of the US, and like, like a bunch of like stock market movements because of those chatters, and confidence and capabilities and stuff like that. So as of August 2026, I'm just listing some model providers out there. There's way more than this out there that have really capable models. But obviously we just don't have the space to put them all out. So like a few models or model providers that might be interesting to learn the names of if you're not familiar. Kimi K3, obviously, it's from Moonshot AI, coming from a Chinese lab. You've probably heard of DeepSeek V4 or DeepSeek, and then they recently in July came out with DeepSeek V4 Pro. There is Alibaba, which has a model family called Qwen. There is a company called Z.AI, and they make something called GLM 5.2. These are all frontier models, by the way. Like they're extremely, they're really, really big models and very capable, and we'll see it in the next slide. Like or I guess earlier this week, Meta released Muse Glimmer, like literally 2 days ago. Had to revise this slide last minute because of that. So there's a bunch of different models out there. Many people are aware of the Claude family from Anthropic, ChatGPT, or the GPT family from OpenAI, or maybe Gemini from Google. But there's like hundreds of different model variants out there. Each has their own specialties. Each has their own strengths and weaknesses and stuff like that. And then it only keeps improving. And a lot of these open models come from China, and especially the frontier ones that we're seeing kind of like rapid releases. They are certainly kind of like predominantly coming from Chinese companies. So the whole idea is to not kind of like, like you don't need to memorize any of the list or anything like that, but just know that, these might ring a bell as the competition heats up over time. Cool. Okay. So a couple of things to note. Why do we even care? Like, like we have some models, we have, OpenAI, Anthropic. Why do we even need to care about any of these? A couple of things. One is capability. So if you've heard of the Kimi K3 launch, for example, a lot of chatters out there that says, hey, this is a really, really good model. rivals the top of the US closed source models and stuff like that. So this comes straight from their publication around their model capability, and not going to go into too much in detail around different kind of like these different benchmarks, but across just different things that they measure how capable their models are. You can see, like, other than Fable 5 or maybe like GPT 5.6 Sol, which are the two most advanced closed source models, they're right there with everyone. And then kind of like if you look into it, it's really not that far off based on some of these benchmarks from models from kind of like open source families. And so, this is actually not true 3 months ago, back in May, I think, if I remember correctly, where a lot of the kind of like the open source models are still pretty lagging behind the capabilities of the closed ones. Now, benchmarks are one thing. Like, my advice is to take it with a grain of salt. You have to apply it to your own workflows to see kind of like what the behavior feels like, what does it fail, where does it break, and where does it perform well, kind of thing. So, like, I would never hold this to be authoritative or anything. It all depends on what you're trying to do with it. And so we'll get into kind of like what that looks like from an analytical perspective, that we'll get a demo for in just a second. Cool. And then the other piece that is important to note is the price. Again, lots of chatters out in the industry around, hey, closed source frontier models are really expensive, and open source models are just way, way, way cheaper. And so, like, for a given unit of intelligence, like, how do we even think about this now? Now that it's, like, the disparity is so huge. And so just wanted to put these models and their pricing on one single chart so that we can see kind of like, what that whole conversation is about, right? If you kind of like, the most capable model here is obviously Claude Fable 5, and it's also the most expensive by a mile. $50 outputs per million tokens. That is substantially higher than any of the bolded ones here, which is all open. So these are the frontier open models out there: Kimi K3, GLM 5.2, DeepSeek V4 Pro, and they are, I mean, like, orders of magnitude cheaper than some of these closed ones. Now, like, does it mean like, oh, like, we will just go, like, use open models everywhere? No. Again, it all depends on the use cases and where it makes sense. Like, if perhaps, like, you really do need the frontier intelligence to be able to solve some problems that you are looking for solutions on, or you may need kind of like, like, very good models at certain aspects to coordinate and orchestrate your workflows. So it all really depends. But generally, kind of like the biggest thing that people have been talking about comparing closed versus open is on price. And obviously on capability, but capability is like, very dependent on workflows and use cases. But generally, orders of magnitude difference in terms of just pricing for per unit of intelligence. Cool. This stat is really interesting, so that's why I put it here. Which is, there's a publication from OpenRouter back in 2025, where even back then, when open models aren't like, nowhere near today's capability, is sort of like, OpenRouter is a kind of like a service where like, you're able to kind of like swap models around, and so a lot of workflows goes through their service because it's very flexible. Like, you're not locked into any one vendor, for example. And so what they found was roughly 20% of their tokens are routed through open models. This is back in 2025. And only 4% of the revenue is accounted for through there, which is just highlighting kind of like the dynamic of demand and just kind of like price between the closed and open models. And by mid 2026, I think just a couple months ago, they've said that they crossed half of routed tokens going to open models. So as models get more and more capable, it's eating more and more of the share of sort of like the workflows out in the enterprise and companies. And again, like everything is very dependent on your use case. So we sort of ran our own pretty simple test as well, where back in June 2026, when a flood of kind of like new frontier open models came out, we actually ran some open models through through the exact same analytics question, and then sort of like hit the answer from the agents, and then we graded them using I think Fable 5 at the time, on did they catch all the gotchas, did they explore all the different angles, did they come up with the answers that were exhaustive, for example, and did they sidestep the landmines that we planted in those data sets. And like this is kind of like a proxy. Again, like nothing is deterministic, nothing is completely exhaustive, so take it with a grain of salt. Directionally, what we were looking for is like, are the models capable enough to do pretty open-ended analysis that has a lot of just different gotchas and stuff with with the right answers and safeguards around hey, no peeking, just kind of like explore the data on your own based on the same exact question and see how they solve it. And generally the takeaway is that they were pretty capable, especially at the time. GLM 5.2 was the latest model and the most capable, and certainly it worked pretty well. And so it's been kind of like 2 months, right, since the test back in June. And so like all the models have only gotten smarter and more intelligent. Okay, cool. So I think we're pretty close to demo time. So generally, how do you actually run one then? Like, it's great, all these things I'm sold. How do I actually run one? A few paths. One is you can run small ones locally. So tools like Ollama can get you a small model running in probably a couple minutes on your own desktop or your own your own laptop or your own desktop. Like literally, your own computer is doing the computation and churning the model through the questions that you ask it. So that's one way. Not super practical, I would say, because the smaller the model, the less capable they are. And generally, let's say for a Mac Mini 16 gigabyte, the standard Mac Minis that you can buy from Apple, like $600 or something, you can run something like an 8 billion to 16 billion parameter model. And for contrast, the Kimi K3 open model is 2.8 trillion parameters. And so that's kind of like how you can think about that. So you really need kind of like state-of-the-art hardware for that to work. But maybe for some things that are a lot less ambiguous or a lot more deterministic, for example, like maybe like just reading some stuff and summarizing it, or copy edit something, that might work already. Second one is hosted API, so you can rent it just the same as you do with, for example, Claude. If we take Kimi as an example, they have their own website, they have their own chatbots, they have their own API keys once you sign up for it, and you can use it as you go, kind of thing. It's still open. It's just that they host the model for you, kind of thing. And then there are other providers where they aggregate different models and stuff, and you only pay for, let's say, one subscription or one bill. And then the third path here is self-host in your servers. So you can spin up your virtual private cloud, or like some private servers somewhere where those machines are still yours, and you can download the model, put it on there, and then run it and have it run over there, and sort of like you talk to it via through that channel. So all of these are just ways that you can actually run one. And in just a little bit, we'll actually do path number two, where we'll hit their APIs. Cool. Yeah. So just one misconception here to clear is that not all, or I guess the frontier closed models are definitely not runnable in your laptops. So like while they're very capable, it is extremely unlikely, unless your computer at home is like so powerful that you can actually run it yourself. So most of the time, these are going to be some hosted servers somewhere that you pay for the token at that pricing schedule that you saw earlier. Cool. Okay, so we are going to get into a bit of a demo here, where we're gonna look at kind of like first swapping the brain of Claude Code. Actually, we're gonna use Claude Code, but with a open model, which is Kimi K3, and then we'll use the same kind of like setup in Claude Code, but just a different brain to help drive the whole operations. Cool. Let's see. Okay. For folks who have been following us for a while, this should be pretty familiar with you. If not, that's okay too. Hopefully, you may have seen kind of like Claude Code, or you may have used it if you have not followed us. One way to use Claude Code is in terminal, and the the workflow that we like to use and that we teach others in our courses is to use it via an IDE like VS Code, which is what I have here, or kind of like anti-gravity, or Cursor, or some other editors. So this one is this is VS Code, and I have a terminal down here at the bottom. I am in a folder that is our AI Analyst Plus repo. So maybe Sean, you can share that link. There is an open source AI Analyst system that Sean has built that is open source. Anybody can use it. Anybody can play around with it. And what it is a sort of like an agentic system that mimics the behavior of a senior product data scientist. So everything, all the best practices for how to frame questions, how do you analyze data, how do you do visualizations, how do you tell a story, how do you construct all of that into a deck or an artifact such that you can convince stakeholders on the findings and recommendations. They're all encoded in kind of like this AI Analyst Plus repo. So we're not going to go into too much detail. You've probably seen us shown this quite a bit before. So what we're going to do is we're going to launch Claude Code using this setup because it's already built, but with Kimi as the brain. So usually, if I launch Claude, right? So I just type Claude on my terminal, and I'm in this AI Analyst Plus folder. I mean, it's renamed to Open Model 101 demo, but it is AI Analyst Plus. Generally, when I type Claude, what I get is I would launch Claude Code, but then the brain is Opus 5, and the model families would be Fable, Sonnet, Opus 5, so on and so forth. So everything from Anthropic. But this is actually very easily swappable. So Claude Code is just a application, and the brain, think of it as an engine that could be decoupled. So in this demo, I actually want to swap this out, not Opus 5. I want to use Kimi. So I'll exit out of this. And I have let's see, I made a few scripts here and I'll share some setup instructions for you all if you're interested in, for example, like try out, let's say Kimi in your own workflow or it works for any other open models. It's very similar idea. So here, what I'm gonna do is I have some scripts here where it will help me sort of like swap out the model, and I'll show you what that looks like just generally. So I have this Kimi and environment file here where it basically all it does is it swaps the engine to Kimi K3 and it's basically pointing Anthropic's Claude Code kind of like path to the Kimi API that I already have. So it is, like it's pretty painless. None of us needs to know any of these. Claude helped write all of these. But the idea is, I just wanted to show you how easy it is. So I'm gonna reset my demo actually. Okay. So I reset my demo and I can just do this source demo Kimi environment. And then basically what I did was I just ran this script, and then it says, okay, the engine is now Kimi K3. And now when I do Claude, I am back in Claude Code, but notice that I'm now running on Kimi K3 instead of Opus 5 or whatever it is. And so I'm going to run a real analysis on here right now. Whoa. Hang on one second. So I have this prompt that we can read together. Let's see, which is using the workflow in this repo. Again, this repo is an agentic system to help answer business questions with data, similar to how a product data scientist would do it. How has the checkout conversion rate trended over time? So we have a data set here that is a fictional e-commerce company called NovaMart. Think of Amazon. So it has all the components that you're familiar with if you shop online, which is, you have a checkout screen, you can start payments, you can complete payments and all that kind of stuff. So the idea here is we want an analysis on how has checkout conversion rate trended over time and what opportunity do we have to optimize it. Output the analysis in an HTML report and then pop it open for me because I don't want to find it for a VP of product. So that's my audience. And I also have a script here where it will help log how much input and output token this analysis used for, like end to end. So this is the receipt.sh file here based on a model that you're using, which is Kimi, and what that translates to in terms of dollar amount. So what I'm trying to do here is to understand when it finishes running this analysis, how much this whole thing costs, and then compare it against, let's say, like other models and stuff. All right, so I am going to fire it off. All right, so it is. So this now sends kind of like this question to Kimi, and we're not going to sit through the whole analysis. The analysis is going to run somewhere between 15 to 20 minutes. We're going to look at what it does, just high level, and then I'll show you the output from another run so that we have an idea, and then we'll finish up and let it finish running. And we'll kind of like close it out with questions and stuff. But I think the idea here is to get an understanding of sort of like, hey, if we run Kimi in this repo, what is its thought process, and how is it tackling this problem, and what its plans are, for example, and what is it doing behind the scene. So we'll take a look at it for just a couple minutes as it churns through. So you can always follow kind of like its chain of thought reasoning. I'll run this through the repos analysis workflow. So it first is trying to get oriented with what the data set is, what this script that I asked it to log tokens is about, and then all the different things that it has access to. Also loading the data set context and stuff like that. And then it's connecting to the data itself, and then figuring out kind of like, hey, has this been run before? What other available information can I get off so that it knows what to do? And so this is sort of like the multi-step analysis, kind of like steps that it's come up with. And this is again going to take probably like 20 minutes or so. But these are all different skills and instructions that we have in the AI Analyst repo. So, high level, what it's trying to do is it'll frame the question and then also define this conversion metric. Like, how do you measure that? It'll run the trend, the funnel, segmentation analysis. It will then validate its findings. In our skills and agents, we have a few layers of cross validations and checks on the final outputs before it's being compiled into kind of like a deck or a doc or something. It will size the opportunity based on the insights. So that's also something based on this repo. It will then build HTML reports and open it, and so on and so forth. So, oops. So these are all kind of like the workflow steps that we have. And so one way to really understand as you use new models in your own workflow is to really understand kind of like the thought process here. Like, does it call the right tools? Is it able to figure out the like how to navigate what is its reasoning for doing certain things, and so on and so forth. Back in May, when the models aren't good enough, what they have been doing was they constantly run into walls. Like, oh, I encountered this error message, then they try to fix it themselves, and then it goes nowhere. Or they're like, hey, let me reframe this question, but then it has no idea what a good reframed question or hypothesis is, and then it'll run in circles, so on and so forth. As models get more smart, as things get more intelligent, those things are kind of like a thing of the past, if you will, and at least supposedly. So in your workflow, the idea really is to make sure that that's actually happening for you. Okay, so this is the previous run that I've run. It's the same exact question. And then it did the sort of like the entire full analysis on that data set. The run that I'm currently kicking off, or in between any of these runs, there is a reset step where we wiped out all the things that it's done in the previous session, so that it can't just peek at the answers, for example, or what has been looked at, or like what it does. Like what the data says, kind of thing, without actually doing the analysis itself. So each one of these are independent. And so this guy is the report, supposedly for the VP that Kimi ran just earlier this morning. So it gave kind of like a TLDR, like a summary of what's happening based on the question. Remember, the question was, how has checkout conversion rate trended over time, and how can we optimize it? And so first question or first title sentence here literally answers that. And the thing that I'm looking for example, because we're intimately familiar with this data set because we worked with it for so much and we taught it for so long, is that there is a component of kind of like a Simpson's paradox baked in to this data, which is hey, high level, the checkout completion rate fell from 68 to 30%, while traffic grew 27x. The fault is in mix shift. So not a broken checkout. So this is the Simpsons paradox that we're expecting the model to be able to pick up if it's, for example, like smart enough, or like it follows instructions or something. This is the real fixable gap is mobile. So it figured out that the checkout page to payment start has a dramatically different conversion percentage between those steps, and then also other levers that it found based on kind of like the different experiments that are available, kind of like the old experiments that we have baked into this fictional data set. And so going down, it's basically just it's highlighting all the supporting evidence, all the different visualizations to help illustrate the story. So what happened? Completion rate went down, but this is mostly a mix shift issue. Again, the Simpsons paradox check. So it is not just a straight up decline that you have to be like super alarmed. But then like the new users, they convert much better. Returning users not so much. But then the share of them have gotten a lot more, and the gap is mobile checkout. So by the way, these are the correct answers since we've used it for so long. And then it highlights kind of like the steps between the steps in the conversion rate funnel. So from add to cart to checkout start, from checkout start to payments attempted, from payment attempted to purchase, between I think this is between web and mobile. And so it's highlighting, hey, this guy, there's a bunch of opportunity here. Everywhere else seems okay. And then it looked at a previous experiment. Again, we would expect a good model to be able to pick that up because that's part of the setup in the repo. And then it does the opportunity sizing. If we fix certain things under certain assumptions, what does it net us in terms of opportunity and whether we should pursue it, kind of thing, so on and so forth. And it's got a recommendation here, and all the receipts on validation methods and caveats is under here. So that's kind of like the output that it's able to give us. And again, because we know this data and this story pretty well, that this is pretty satisfactory in terms of what it came up with.
I mean, it's kind of crazy. I don't know if you want to scroll through some of those visualizations, but it's crazy that like we're now at a point where like agentic analytic systems that we build ourselves, that like we built this, but anyone in this room could build this yourself. This isn't some like crazy like enterprise tool you had to buy, is able to deliver this uh level of rigor and analysis from end to end. But then it's also even crazier that this didn't come from like OpenAI or Anthropic models. Like this came from an open weights model at a fraction of the price. And I don't know. It is for me. I'm like, I don't, I don't understand like how these like frontier labs are going to compete, because if it's already here, it's just going to get better and better and better. There's some threshold of model capability where like you don't need a better model. Like for us at the lab, like we found kind of like the analytics capability kind of hit that threshold in February with Opus 4.6. And so any models that as good as Opus 4.6 can do most of the analytics workflow. And the frontier labs are going to continue to push out newer, bigger, better quote unquote models based on some benchmarks. But that doesn't mean it's better at getting your job done, doing your job faster, doing whatever task you need to complete. So there's just cheaper, more secure, more controllable opportunities for how you can start leveraging AI to get what you actually need to get done. You don't need to be on the freaking most expensive, newest thing that these companies are going to automatically default to you in their products or try to sell you. A lot of the times when I do analytics, even before I was getting into open models, I was just always trying to push back to Opus 4.6 because I don't want the newer Opus models because they take too long and they're more expensive, and I can get the same answer with the earlier ones. Also, Opus 5 talks so stupid. It just actually infuriates me how it talks. I'm like, and I find myself cursing at it, and I'm like, well, I shouldn't do that. Like, I gotta be nice, like I was in the Opus 4.6 days.
It is very AI. That's all I can tell.
Yes.
Okay, cool. Let's wrap up this demo here. So the last thing I wanted to show you guys is how much it costs for these runs that you see. So I ran the same thing on Opus 5, for example, and it was something like $16 for that run if it were to be billed at the API pricing list. Obviously, we have subscriptions here, so like we're not paying on a per run or per analysis basis. So roughly like $16. It came up with the exact same or very similar kind of like outputs, by the way. And then Kimi K3, which was the run that produced the other one that you guys just saw, was roughly $5.60. And I actually have a usage counter myself that I monitor. It is less than that. It was more like $2, $2.50, $3, something like that. And I have another scratch run here that was like $6.50. I think this was like also like $3. So there's some discrepancies from how it does the token counting and kind of like the charges. Take it with a grain of salt. The directionality is what's interesting here. Okay, cool. So let's get back to the slides here. All right, gonna wrap up really quickly. Let's see. Cool. So if you are interested in, let's say, like an open model, to learn more about it, or anything, or specifically with Kimi, for example, since that's the latest and greatest, you can go to kimi.ai. That is the chatbot equivalent that you can see. It's no different than from the things that you're familiar with, like Claude or ChatGPT. Very similar interface. If you want to build on it, use the API or a subscription with them. You don't have to subscribe with them. You can subscribe with other sort of like hosted providers as well, like Ollama. We don't have time to demo it today, but like we'd love to show you guys at some point for those who are not super familiar with that. And you can even download the weights. I think they just literally published it maybe a week or two ago. And when is an open model the right call? So if you have a lot of volume, so for example, like, hey, I have to do a ton of analysis, or I have to design a ton of agentic systems, or whatever it is, volume, typically there's a break-even point where it makes no sense to continue to pay for sort of like certain models if you can move it over when the capability is already there to save on cost, kind of like as your volume scales. We talked about control, and the third one, which we teach in one of our courses, is around using different models to check each other's work, especially now that frontier models are getting pretty smart. They can actually do this pretty reliably. Like you have more options, not just, let's say, like one model that you have to trust it, or figure out ways to have it be as trustworthy as possible. But you can actually have a symphony of different model families to check each other's work, and that's a powerful validation tool as well. All right, so this is the last slide. We have more free lessons coming up for those who are interested. Next week, we have a free lesson around building semantic layer, so AI can define your metrics. None of these is possible if you have not even defined your metric yet. AI is just going to guess, so it doesn't matter how capable the models are. If the very basics of doing the foundational work of what does checkout conversion rate even mean is not defined, it's not going to save you. So pretty important topic, and excited to talk about it. Sean's going to be the instructor on that one. And then we have a couple paid courses. Folks who've been following us are pretty familiar with these. The first one is on agentic analytics, building the AI analyst system itself. So building the agentic analytics system that tailors towards your workflows, your needs, and your data, stuff like that. 5-week course that starts in September, where we go through quite a bit of how do you build one from scratch to how do you bake in evaluations, context. We go deeper into open source models as well in those 5 weeks. If you scan it or use the link or use the code here, you get 20% off for the upcoming cohorts. And then in parallel, we have another course around just the foundational knowledge of analytics. So how do you ask really good questions and then let AI execute the rest? The idea is to help everyone to be, kind of like develop the human skills that are still needed in the age of AI, where you understand sort of like what does good look like in terms of doing really good analysis, in terms of what the in between components are to make a question leading to a decision, a insight leading to action, and everything else in between, but leave the rest of the execution pieces to AI to help you get to help you actually get at what matters for the business.
Yeah, maybe a little bit more on the agentic analytics one that's coming up in a few weeks. It's really freaking good. It's so we've ran this 5 times now. We've had over 250 people go through this. It's got like a 4.9 on Maven. There's no other course like this right now that teaches you to go from literally never used Claude Code or Codex or anything before to by the end you're using multiple models, Claude Code, Codex, open models. You're going all the way from like building your own system from scratch, learning all the foundations of agentic systems to learning around how to build AI evals, which is just an extremely important skill for product development in general. But we go specifically into the use case of AI evals for analytics cases, which is very different from other products, by the way, to context engineering and management, where like we're finding this is what makes the like open models and like more affordable models like extremely capable and reliable, is like being able to have this like really systematic way of approaching how you manage the context of your business and your data in such a way that agents can read it. And it's very bespoke to every person's individual company. So we go through that. A lot of our free stuff we do, like every week, we have these free lessons, and they're usually more like of like us talking and doing a demo. These courses are extremely hands-on. So you're building the entire time. We actually have a rule in our courses when we develop them that we won't talk for more than 10 minutes in a row at you before we start building as a group. So highly recommend that. If you have any questions at all, email us or reach out to us on LinkedIn, or we're happy to hop on a call with you as well. But that's a really cool course. Hope to see some of you there. I know we had a lot of questions in the chat, but I think I got to most of them. But if anyone has questions on open models for the last few minutes here,
throw them up. Looks like the other run finished as well. This one is a little off. Yeah, I'm not going to read it, but it seems like it did figure out the thing. Anyway.
We had a question here from Caroline. Want to build layers and tune an open model?
Build layers and tune. Let's also cover that. What do you mean by layers, Caroline? If you're talking about like fine tuning an open model, we don't actually do that in our course. There's a bunch of different resources online as well. We try to just cover the kind of like the practical things around how to use it for analytics workflow. So not so much on tuning the model itself. Hey, Valens, what's up?
I was just going to ask on that same question about fine tuning. have you guys in your usage had to ever go through and like fine tune a model? Because I know it can be expensive and time consuming and stuff like that. So just curious if you've had to and like what was the situation around that?
Yeah, no, we've not had to fine tune anything. Fine tuning, I think, would be really powerful if you have very much like proprietary data and you have a lot of it, for example, that would materially differ from the base capability and what, for example, building your harness would allow it to do. So I think I don't think we've had that thing encountered yet because we're more general purpose in the lab here.
Yeah, I think like I've used some fine-tuned models for in the legal space when I worked there. And I did find like, things like, if you read a contract from a lawyer, like to me, it's always like, I don't know, this looks like a legal contract. Um, I do find that like pulling out the like semantic like different discrepancies is done a lot better by like a say like legal bird or something like a model that's fine-tuned on a bunch of contracts. But those are fine-tuned in other like public legal information. We've never like done it ourselves.
Okay.
Good
No,
questions.
that's helpful. Those very specific domains that a general model wouldn't have all the data to train on. So that's really helpful.
Yeah, yeah, totally. I think healthcare is one aspect, and then some stuff, for example, for companies that really don't want, let's call it like Anthropic to notice the trade secrets. I think those are very well suited for fine tuning.
Thanks everyone.
Thanks all.
See ya.